going to do one last lesson on the linear differential equation of the first order. I want to remind you that this is the exact form the equation must be in. Here, P and Q are functions of x only. And in today's lesson, we're going to look at finding a particular solution, which means after we go through the required steps to find that general solution, we'll be able to solve for the constant c. And so I intend to go through 3 examples with you. So let's have a look. The first one is not in your textbook. Oh, I've got our formula sheet here as well. Here we go. Here's the first example. Okay, we have x dy minus, and in brackets, 2y plus x cubed cos x dx is 0. So in transforming that equation into this one, you can see that a couple of steps are required. We have to open up this bracket, so distributing both the factor of -1 and the differential dx. Okay, so I'll do that first, and that would look like this. So we will have -2y dx and -x cubed cos x dx. Okay, so again, just distributing both this factor of -1 and the differential dx. Now, which 2 terms should remain on the left side? So it should be clear to you that the one containing y, which is this term, should remain on the left. So we're going to move this term to the right side. And of course, it will be added. So this will now look like this. Okay, so we will have here equals x cubed cos x dx, like that. So looking pretty good. You should note we need dy isolated, so we're going to now divide all terms by x. So this will be 2 over x. And here, when we divide x cubed cos x by x, it will be x squared cos x. All right, and in this way, we can directly compare the equations. It should be clear to you that x squared cos x is q. Now, what about the value of p? P is the most important value because it determines the integrating factor. So not only does it include the 2 over x, but also the factor of -1. So p is -2 over x. Okay, and from there, let's go ahead and find our integrating factor. So as you know, the integrating factor is e to the integral of p dx, so it's e to the integral of -2 over x dx, which means it's e to the -2 ln x, like this. -2 becomes the coefficient on x. Sorry, -2, which is the coefficient, becomes the exponent on x. And then this becomes x to the -2. So our integrating factor is x to the -2. Now we can move down to this part of our solution. So on the left side, we will have x to the -2 times y. On the right side, we'll have the integral sign, the original function q. Remember, that was x squared cos x. Then x to the -2 and dx. Okay, so again, the left side is the integrating factor multiplied by y. Put in your equal sign and your integral sign. Here we need the original function q, which is x squared cos x, right here. That's q. It is multiplied by the integrating factor before integrating with respect to x. All right, so we've perfectly got this set up, again, in accordance with this equation here, which works every time the original is of this form. All right, so let's look at that right side. So before integrating, of course, we should simplify. Well, we have x squared multiplied by x to the negative 2. And what does that become? That becomes x to the 0. So this is the integral of x to the 0 times cos x, which is just the same as the integral of 1 times cos x. Okay, so of course this is multiplication of powers with the same base. We simply add the exponents. So we add 2 plus negative 2 to get x to the 0. And x to the 0 is 1. So the right side now is simply the integral of cosine x. I think you know what this is, but if you have any doubt about the sign, you know, just check here. And when I say sign, I mean the algebraic sign, S-I-G-N. Whether it's positive or negative, you just use your formula sheet. So the integral of cosine is positive sine. Okay, so we get sine x plus c. And this is the point at which we would, if we were finding the general solution, we would now divide both sides of the equation by x to the negative 2 in order to isolate y. However, when we're going to be solving for the constant c, which we are because in this example we were also given this information, y is pi squared over 4 when x is pi over 2. I find it's easier to solve for the constant before dividing both sides by that integrating factor. So let's leave this as the left side, this as the right side, and now let's use at x is pi over 2, y is pi squared over 4. So that means we can substitute that information. So on the left side here, it's pi over 2 to the negative 2 times pi squared over 4. So that's the left side, which was x to the negative 2 times y. On the right side, we need the sine of pi over 2. And here we have plus c. Okay, so we should be able to simplify this left side and work out the value here as well. Okay, so let's do that. So the left side is 1, and how shall I explain that? Well, pi over 2 to the negative 2 is the same as 1 over pi over 2 all squared, right? So this is the same as 1 over pi over 2 all squared. And that is multiplied by pi squared over 4 on the left side, you see? Okay. And pi over 2 all squared is the same as pi squared over 4. So the left side now becomes pi squared over 4 all over pi squared over 4. So we would bring this square in here, so pi squared over 4. So left side is pi squared over 4 over pi squared over 4, or 1. Okay, what about the sine of pi over 2? You might note that from the graph that that's equal to 1. And if you don't know your graph by heart, you know, just make sure your calculator's in radians and you can just do the sine of pi over 2, right? Equals, you'll see that that's equal to 1. So now what do I have? I have 1 is 1 plus c. So that means c is 1 minus 1, or c is 0. So we end up with c equals 0. And so that means right here is a 0. So our equation now simply becomes x squared y. So that was the left side. We could write it all the way down if you like that better, but not x squared y, sorry. X to the negative 2y is the left side, equals sine of x. And now it would be plus 0 right here. So if you want that, you can put that in, plus 0. And now that c has been determined, we solve for y. Y is found by dividing both sides by that same integrating factor of x to the negative 2. So we'd have sine x over x to the negative 2 here, like this in our answer. Ooh, my ruler is so far away. Okay, and that's just a little odd to leave the negative exponent in the denominator. This is the same as x squared sine x. So y is x squared sine x is the final particular solution. Okay, so if you want to compare this to the examples we did in the last 2 videos, when we got up to this point here, all we would have done is isolated y by dividing both sides by x to the negative 2. And c would remain in the final answer. But now, since we're given this information here, we were able to first go ahead and determine the value of c, then substitute it, finally divide both sides by that integrating factor. Okay? All right, so for clarity, I'm just gonna put a faint line here, okay, separating where the beginning of the solution starts. So I hope that one was all right. That's just our first example. Let's go on and look at a next one. Okay, so the next one that I've selected is from your textbook. It's problem 32. It says dq minus 4q du is 2 du. So this is certainly complicated by the fact that we have these letters Q and U. So if that's going to bother you, you can go ahead and change the lettering right off the bat. So it's important that you do it correctly though. I mean, you can kind of see in comparing here that the Q is Y and the U is X. And so maybe I'll go ahead and do that for you, just so you know you have that option, okay? So you would do here, dy minus 4y dx is 2 dx, and further, y is 2 when x is 0. Okay, and then perhaps at that point you're ready to start. So here we go. Look at the equation here. Compare it. And I don't think anything has to be done. It compares already perfectly. So Q, here's Q. Q is 2. What about P? And please don't say that P is 4. Remember, the sign in front here has to be included. So P is actually -4, and that makes a huge difference in the calculation of your integrating factor. Okay, so be careful. All right, so P is -4, and so our integrating factor is e to the integral of p dx. So it's e to the integral of negative 4 dx. And what's the integral of the number negative 4 with respect to x? It's simply negative 4 times x. So now we have our integrating factor. And of course, once we have that, we come all the way down and set this up. So left side will be the integrating factor multiplied by y. So integrating factor multiplied by y. On the right side, we begin with the integral sign, and then we're going to write q times the integrating factor dx. So q, remember, was 2 times the integrating factor, which is e to the negative 4x, and then dx. Okay, so integral q. This is the integrating factor and the differential dx as required. All right, so in integrating this right side, you know, the constant there can just be pushed out of the way, and integrating a straightforward exponential function like this one is very simple to do. We don't need a u substitution or anything like that. All we do is we repeat the exponential function, but in front of it, of course, will be 1 over negative 4, because negative 4 is the derivative of negative 4x. So this method is used anytime the derivative of this exponent is just numeric. Okay, so the 2 that's there already simply will multiply now by the 1 over negative 4. And we cannot forget the constant of integration. So the right side now is 2 over negative 4, or negative 1/2 e to the negative 4x. And the left side is still the same. So if you like having it, you can write it all the way down the left-hand side like that. So if this were a problem where we were not given this additional information here, then we would at this point solve for y by dividing both sides of the equation by e to the negative 4x. However, we can use this information. So y is 2 when x is 0. We can use that now to solve for the constant c. So in the left side, we're going to substitute a 0 here and a 2 here. And in the right side, we're going to substitute a 0 here. So then you can see that this will become left side e to the 0, because it's negative 4 times 0. So the left side, e to the 0 times y, which is 2, equals right side, negative 1/2 times, again, e to the 0 plus c. So there's our equation with these values substituted for x and y. Well, as you know, e to the 0 is 1, so left side is now 1 times 2. Same thing here, this is 1. So we have negative 1/2 times 1. So this is how we can solve for c, by taking 2 and adding a negative 1/2. So c is 2 plus 1. I said that wrong. Taking 2 and adding 1/2. So c is 2 plus 1/2. Okay, and here, you know, probably gonna go with fractions since we've already got a fraction here in this term. And so this is 4 over 2 plus 1 more over 2, so we end up with 5 over 2 as the value for c, 2 plus 1/2, 5/2. And so that's what'll go right there. So now we go back and we write left side equals right side, but with the number 5/2 there. So let's do that. Left side equals right side, but here plus C becomes plus 5/2, like that. Okay, and now it's the right time to isolate y by dividing all terms by e to the negative 4x. So this will be y. You can see that when you divide this term by e to the negative 4x, you'll just have -1/2. And this term would be 5/2 divided by e to the negative 4x, but that's the same thing as 5/2 times e to the positive 4x. And lastly, it makes sense to common factor a half here. And if we do so, this will be -1 plus 5e to the 4x. Okay? So in writing the final answer though, I'm going to remember that I changed the variable q to a y and the variable x to a u. So I'm going to write that now as my final answer with q here and here with a u. And I'm going to change the order of these terms because generally in this case we would write it that way with the positive term first. And there it is. Our second example is now complete. And again, I'm just going to do a faint line here to separate where the solution began. So again, work out P, get the integrating factor, solve in the same way we did in our last two lessons. But before isolating y, I would suggest you solve for C. You can substitute it and then isolate y. I just find it's a little easier. Okay? All right, let's do one more example together. So again, I took this one from your textbooks. It's problem 34. It says y prime times the square root of x plus 1/2 y is e to the square root of x. And we are given these conditions. X is 1 when y is 3. That will allow us to solve for that constant and to come up with a particular solution. So I've got to clean this up. In particular, you know, y prime is dy by dx. So I will start by multiplying all of these terms by dx. So that's going to leave us with dy square root of x plus 1/2 y dx is e to the square root x dx. Okay, so I kind of did two things there. I changed y prime. It's a strange looking prime actually. Does that bother you? It's so upright. Okay, anyway, I changed y prime to dy by dx and multiplied all three terms by dx, and that gave me this. But I know that the first term here should just be dy, which means in my next step, I should be dividing all terms by the square root of x. So I'm going to do that as well. Just trying to think of the nicest way to write that for you in this term. Okay, I'll just go with something. So yeah, I'll just do it like this for now, but I will definitely be changing that. because that's super awkward to work with. But I'll do the same thing here for this step. And then again, we'll look at how we can improve that. All right, so here's what we have. I would say that since we are doing calculus, these radical signs are not helpful to us at all. So each of these should be changed into x to the half. So this here, this here, this here. So all three of those would then be written x to the 1/2, and that's going to help quite a lot in simplifying the terms. Because when you divide by x to the half, it's the same as multiplying by x to the -1/2. So now this term will look instead like this. X to the -1/2 times y dx. Much better, right? And here, x to the -1/2 times e to the square root x, but square root x is x to the 1/2 and dx. So that's much, much better because we're going to be integrating and so on. So we definitely don't want radical signs. So again, here we had x to the half and here as well, but dividing by x to the half is the same as multiplying by x to the -1/2. And now we're all set. You should see that this right here is q. You should be able to tell me also that p from this term would be right here, positive 1/2 x to the -1/2. So that is what our p is. So let's begin by stating that. So p is 1/2 x to the -1/2. And so that means the integrating factor is e to the integral of 1/2 x to the -1/2 dx. Okay? So the 1/2 here, of course, remains just as a multiplier. And now we integrate x to the -1/2. And how is that done? All you do is add 1 to x to the -1/2. So that is positive 1/2. The new exponent is positive 1/2, and in front of that, of course, would be 1 over positive 1/2. Okay, so there's a lot of halves involved in this question. But this 1/2 here is still right here. This right here, this part I'm kind of circling with my pen currently, is simply the integral of x to the -1/2. We've simply added 1 to the exponent to get the new exponent, and we've divided as required. Okay, so this simplifies to 1, okay, because it's the same as 1/2 times 2. So what is the integrating factor? It's e with an exponent of x to the 1/2. That's the integrating factor. All right, so now that we have the integrating factor determined, we are going to set up this equation. Integrating factor times y. Integrating factor times y equals, on the right side, begin with the integral sign, then write q times the integrating factor dx. Now, remember, q was all of this stuff here. So q there's q multiplied by the integrating factor, and then there will be a dx. Okay, so again, here was the q, integrating factor dx, and all of that follows the integral sign. Now remember, it's extremely important to simplify this fully before integrating. So let's do that. You should tell me what this would be. It's multiplication of powers with the same base. When you multiply powers with the same base, you simply add the exponents. What's x to the half plus x to the half? It's 2x to the half. So this is what we have to integrate. Now this, I think, is going to require a u substitution. So let's go to the bottom of the page and fit that in, okay? So here's the integral I would like to work out. Right there. So what do we call u in this case? When we've got an exponential, it's the exponent that we make u. So u is 2x to the half. What's the derivative of that? Well, it's 2 times 1/2 x to the negative half. In other words, it's x to the negative half. Okay, so the half comes forward, multiplies by the 2 to give you 1, and then you subtract 1 from the exponent. So that's our du. So let's look over here then and see what we have. Well, this is e to the u, so we have to write that in. E to the u will be written here. What about x to the negative half dx? It's exactly du. So we simply have here e to the u du. The integral of e to the u du is just e to the u plus c. So in this case, it's e to the 2x to the half plus c. So that's the appropriate integral that goes right here. Okay, so I'll put a little star here corresponding to working out that integral. Okay, so if we hadn't been provided with this information here, we would now be all set. We would simply isolate y by dividing both sides of the equation by this integrating factor. Okay, however, instead, we are given these values for x and y, and so we can use them to solve for c. But I feel like I'm a little bit out of room, so I'm going to go on to another page to do that, okay? So let me just see if I move that there. Is it still visible for you? Yep. Okay, so I am going to start from here and substitute into it, but maybe I'll just write it down again. So that's the left side, that's the right side, okay? And into that, we're going to substitute the given values, which are here. X is 1 when y is 3. Okay. All right, so let's go from there. So again, I simply wrote this part on the left, this part on the right here. Now we're going to substitute and determine the value of c. So we're going to have here e with an exponent of 1 to the 1/2. Well, 1 to any exponent is 1. So this is going to be e to the 1, which is the same as e, by the way, times 3 is, now what about here? E, and it's, the exponent now will be 2 times 1, so e squared plus c. So we have 3e is e squared plus c. So how do we find c in this case? We would subtract e squared. So we now have C is 3e minus e squared. Now, this looks weird. It's just a number though, right? If you wanted to work it out, you would go 3e to the 1 minus e squared. See how I did that? 3e to the 1 minus e squared. And it's that number, okay? But I would rather not have that in our answers, that kind of, since it's not something exact, we're better off leaving this expression. We'll just put this expression right here. All right, so we go back to that line here now and write it out. So plus C becomes plus 3e minus e squared. Just like that. And now we're so close to being done, except we're going to just isolate y by dividing the terms by this exponential here. So we're gonna have this one. Now what did I do with the ruler? Oh, there it is. I'm gonna have this term divided by that integrating factor and also the constant. So I'm going to keep the constant together like that because it's just a number, and it too has to be divided by that integrating factor like that. Okay, you see that all right? And so division of powers with the same base. So what do? We subtract exponents. So we have 2x to the half minus 1x to the half. So that's going to give us x to the half. And here, I mean, we could just leave this underneath or we could bring it up. So it's kind of up to you what you do here. If you bring it up, it would have a negative exponent and it would be in front of that. Or you can just leave it underneath. Maybe I'm going to leave it underneath because I'm going to go to radical form since that was the form presented in the original problem. Okay, so final answer, here it comes, the moment you've been waiting for. This becomes the square root of x. And under here as well, we have the square root of x. Okay? Okay, so finally that third example, which is a rather lengthy one, is complete. Okay, I hope that you're understanding the process well. Remember, it's imperative that you get the equation in the correct form first. The form has to match this one so that you can determine P and your integrating factor. Once you have that, you can jump way down to here. After integrating, if you're given information like this, you will be able to go ahead and solve for that constant of integration. Once you have the constant of integration determined, plug it in and then finally isolate y by dividing both sides by that integrating factor. Okay? All right. Thanks so much for taking the time to watch the videos. I hope that you are also taking notes for yourself while you're doing that. And if you're not actually copying down all the notes, maybe you've got some way to take screenshots of my completed pages. I don't know. But in any case, you do need copies of all of these because, as you know, your unit tests will all be fully open book, and I'm sure that you'll want to have copies of all of these examples at your disposal. Okay, thanks, and please try the recommended problems from your textbook. They are posted in Blackboard. Have a great day.